Welcome to my channel. My name is Opubo. For those of you new to the channel, I bid you welcome. For those of you who are returning to the channel, I bid you welcome back. Good to have you back. You are all well appreciated. As usual, this channel, I present various ideas and designs of technologies, mostly from the Technology IP Bank of Enhanced Knowledge, often integrated from several other technologies already in the bank and made ready for adoption by the Adoption Brokerage Division. This presentation focuses on atmospheric carbon capture technology to the extent that the technology has a role in conservation economy. More specifically, the technology focuses on the utilization of atmospheric carbon dioxide as resource for utilization in the production of chemicals for chemical industry, as already presented in an earlier video, GGS methanol process technology. The link is presented below in the pinned comments section. Yet, seemingly also addresses the concerning issue of global warming and as such enabling a conservation economy from the technological perspective, and the approaches citizens of a geographical space, be it a community, a region, or even a nation, could adopt to ensure the sustaining of a conservation economy, strengthened further from the utilization of atmospheric carbon dioxide. That carbon dioxide is in the atmosphere and so available to every geographical space makes its utilization as resource all the more critical to the sustaining of a conservation economy. As such, use should provision citizens of a geographical space essential resource for the needs of existence without the dependency on another region. Invariably, all and each of the other air gases prefers that option of utilization that necessarily empowers conservation economy. Of course, utilization of carbon dioxide must necessarily entail the extraction of carbon dioxide from the atmosphere, in which it exists in small concentrations and must be accumulated into vast quantities suited for industrial operations for some products such that may be derivative essential needs as defined consequent on the prevailing civilization and the underpinning sciences. The option to first consider carbon dioxide does not imply any superior standing of this gas over the other air gases, as each is equally a resource, but rather the choice of first considering carbon dioxide obtains consequent on the immediate consideration of global warming. Digressing for a moment before making a deep dive into the matter of carbon dioxide extraction from the atmosphere, if you have not as yet subscribed to the channel, I implore you to do so. Please subscribe to the channel now by simply clicking on the subscribe button below the video screen. The subscription would cause the system to keep you informed by notification of the next presentation the moment one is published. Then, of course, the subscription will also help me to more consistently continue to elicit the peace dividends of conservation economy. Now, back to the presentation. By the science underpinning this prevailing civilization, carbon dioxide is an essential need for citizens, inhabitants of a geographical space engaged on conservation economy, as was also identified in the context elicitation regarding algae cultivation that required carbon dioxide and algae being useful for many needs of life. Until the recent concerns about global warming, now euphemistically called climate change, there has been no disposition to extracting carbon dioxide from the atmosphere as a resource, though its presence has always been known. So the manner of availing society of carbon dioxide has not been of interest or contention. Yet, some entrepreneurs did devise various means of accumulating carbon dioxide for sale to algae cultivators. One of the aspects of troubling aspects of carbon dioxide extraction from the atmosphere as resource, though, is that there has not been much motivation, as much chemistry does not yet exist about its utilization. However, presentations in prior videos has constructed much chemistry about the utilization of carbon dioxide as resource, so seems rational to turn to extracting the gas from the reservoir of the atmosphere that prevails, as is the object of the technology of this video presentation. However, that the atmosphere presents a vast reservoir of carbon dioxide has been argued by some as untenable in cause of expressed concerns about the exhaustion of carbon dioxide with industrial scale continuous extraction. Yet, the extraction of the carbon dioxide from the atmosphere has been argued by some humans as would be damaging to life itself and should not be undertaken. Some have argued that any depletion below the standard 0.03% would severely impact the sustenance of life as plants would begin to wither. Of course, admittedly, the capture of natural gas, natural resources of all classes have been performed and attempted in various ways, and occasionally even resulted in the damage to the environment. In that regard, the large-scale extraction of carbon dioxide would need to be performed under careful caution for monitoring significant and impactful deviations from the standard concentrations of 0.03%. However, the need of conservation economy requiring operations at industrial scale, the extraction of carbon dioxide from the atmosphere also has to be performed by means that enable large volume production of the gas. The technology of the presentation prefers one such option being built out of the air-gas separation medium already in the technology bank, and was the product of an earlier video presentation titled Air Gas Technologies, the product of which are specification-based separation media for the normal temperature separation of gases, though initially developed for just air gas separation, deployed in this technology as is shown in the image. Conceptually, atmospheric air is pumped into the process equipment built out of the air gas separation medium and is separated such that carbon dioxide is extracted from the air and accumulated. This technology gives a comprehensive design for the separation of air gases. By design, the technology consists of three sets of process equipment: air intake conduit or stack, air cleanup compression system or extraction system, and the air gas separation equipment set in bundles. The cleanup compression system has three primary components: air filter rotary equipment, sanitation by a reactor, and high volume air compression. During operation, pump is turned on and starts pulling air through the intake conduit. The air flows into the rotary filter and is cleaned of dust and some bacteria. The outlet of the filter equipment is connected to the compressor, which discharges the air by pipe into the sanitation by reactor inlets, in which germs and pathogens are sanitized, essentially destroyed. The outlet of the bioreactor is connected to a confluence that distributes the air stream into the air gas units. Ultimately, the air stream fed into the normal temperature air gas separation equipment is split into carbon dioxide and other gases in compliance with the medium performance specifications as given and followed in the production of the separation medium. Availed with the air gas separation medium as the product line of the air gas technologies in the previous video presentation, there can be uniform acceptance at this time that there is, in fact, a technology for large-scale continuous extraction of carbon dioxide from the atmospheric air, and hence permits the utilization of this resource available to every geographical space and consequently enables conservation economy. Notably, but for the separation medium, the materials of construction of the technology being mainly steel, the technology provides opportunity for the adaptive reuse of discarded equipment and devices in every region, allowing for the elimination of matter that would otherwise be branded waste. So under the requirements of conservation economy, this technology has a significant role in the sustaining of conservation economy. Now then, if interested in licensing this technology, please send an email to me. The email address is put in the pinned link below, as are other useful information. Regarding licensing considerations, there are some notes that should be of interest. Worthy of note of the technology design is that the air-gas separation process, being modular as presented, can be, and in consideration of the low concentrations of carbon dioxide in the air, may have to be built into a bank of modules to meet the processing needs of any target industrial operation. The number in the bank of such deployment could go anywhere from 25 to 50 to 100 equipment. In that case, the bank of air-gas separators, of course, must necessarily be integrated as explained in a previous video. Further, the air extraction system or the clean-up compression system pulling the air in from the atmosphere through the intake conduit is intended to be manufactured by an affiliate and sold by any licensee of the technology. The licensee will have the licensing privilege of manufacturing the air-gas separation equipment, so insurance concerns of performance is at the operations of the licensee. That said, I wrap up the presentation by saying to you, thank you for being here, and I appreciate your coming to listen and viewing the presentation. And if you have not subscribed as yet, do please subscribe to the channel now. I do hope and expect that you would consider coming back for the rest of the future presentations of the varied technologies. The fact is, even if you do not adopt the technologies, some might just change your perspective of society and life. Until the next presentation, I wish you be well.